Well, good afternoon. It is a wet, cold, rainy, right after Christmas Day, 2021, and I had a project I was going to refresh, but I'm pretty sure I've never shown anybody. What I'm looking at right here is Fusion 360. This is not for commercial views, so I am not monetized in YouTube, nor in any way will I make any money off of this endeavor. What we're looking at here is a gear that I've quasi-designed with the help of Fusion 360 that will actually fit on my Harrision M250 lathe change gear. I did not get a full set of them. Here, in fact, is a original factory one. All right, and this one is a 40 tooth. There you go, 40 tooth, and you'll notice it has a quite unique, not a single keyway, but a spanned 6 spaces around it. This is a module 1.5 gear, and it is made of unobtainium. You can get them, you can have them printed, but I've invested a lot of time, a lot of, well, depends who's asking, a lot of money getting to where I can 3D print my own if I need them, only for my personal consumption. And from that one I was going to show you just kind of how I did it. Here's one on screen so you can see it. Obviously you can rotate it around and look at the tooth pattern. If you look at that, very, very uniform. The 3D printer will do a really good job of recreating this. One issue, it essentially has to compensate a little bit for shrinkage. Now if you look inside the splines, there are different surface areas in here. I haven't saved this, but you can kind of see how this is distributed. But if you look really closely at the splines, it is square here, but it's square and it is riding on an outer race. And then so that leaves these right here with that pointed space. Now I've made several of them. I wasn't going to show you just what I had done on one of them, but I thought, well, took me a long time to get it. There was a lot of YouTube videos. There was a lot of this, a lot of that using Fusion 360. I thought I'd just show you because once it's all done, it's not too bad at all. Hopefully, as is typical with YouTube, I hope I get a lot of help off YouTube, so I thought I'd share this with you. So, okay, let me get set up from a blank page and I'll show you how to get from 0 to here. All right, I'll bring you right back. Okay, brand new design, just came up here under file, new design. All right, before you go too far, go ahead and click save, give it a name. Now, this uses cloud storage on this free version, so I'll just share that with you. Let's call this one, let's go cloud, 44 tooth Harrision gear for YouTube. Okay. Storage, I've already got a folder set up. I've already done it once just to go through the motions again, remind myself, but I'm going to save it again into the same area. Click save. Okay, so now up here you can see that there is a cloud 44 tooth Harrision, etc. So we've got a blank page. And you can move this around. However, I'm not going to try to make you an expert in Fusion 360 because I am far from anything close, barely. Other than barely being functional, I'll go from there. Okay, so the first thing is there is a very neat trick inside Fusion 360. If you look under the tools, you're going to see something called add-ins. This is what took so long to find. If you're trying to draw spur gears on screen, God love you, have fun, but there's a much easier way. All right, so tools, add-ins. Under that, there's scripts and add-ins. Somebody's already done a lot of work on our behalf, so let's go into here. And there's a list. There's some generic ones out there, bolts and bottles and all kinds of other stuff. If you keep scrolling down, there's spur gear. Spur gear. All right, this is a macro. I'm going to click run and it's going to bring up a sub menu and we're going to get started. And I'll put all the stuff on the screen. Hopefully you can see that right over here. I'm going to bring it over so you can see it. Now here's where the magic is. We're making a metric gear. We could make an English gear, no problem. Pressure angle, we're going to leave it at 20 degrees. The module, we're going to go 1.5. Okay, the number of teeth, I believe we decided on 44 because it's a nice size. Don't worry about the backlash. We're going to come back to this in a second. Gear thickness. 10 millimeters is right about where the factory gear is. So I wouldn't go much more than that. You're not going to gain a ton more strength in it. Again, these are going to be expendable gears. You can run them, they'll be fine. Again, they're only moving the carriage. They're not doing anything dramatic as far as carrying the load of the spindle. So from that one, let's go 10 millimeters. And then the hole diameter, I'll put these in the documents here. The hole diameter is going to be 22.97. The measured is 22.95, but shrinkage, when you print this stuff, it's going to draw up a little bit. Again, these are going to be really, really close, so don't worry about it. But what I'll mention now is right down here, there's an error message that says the root fillet radius is too large. It must be less than 0.885. All right, so this is the one that's causing you the issue. Go 0.885. Okay, now pitch diameter, that's handled by the tool itself. 20 degrees, 1.5 module, 44 teeth. Not going to worry about the backlash. We're going in plastic, and the gears, when you bring them up on the banjo, it's going to be adjustable, so the backlash is something you can control. Root radius, we just adjusted that one. Gear thickness is 10 millimeters. Hole diameter, I bumped it up by 0.02 millimeters because of the shrinkage. I just want a nicer fit on the spline. Normally I go 22.95, and then we go. All right? Boom. Give it a second to get his breath. Boom. There's your gear. Wow. Boy, that was pretty easy. Absolutely. Absolutely. So there's a beautiful gear rendered for you and ready to go. The big problem now is, okay, Dan, how the heck did you do that spline? Okay, so we've generated the spur gear. I'm going to clip out the previous version I was doing there. It kind of got screwy. What it was doing, it was carrying in attributes from our previous one, and it was causing me heartache. So, okay, right from here, I'm going to do an L, which is going to draw a line. Don't worry about the dimensions yet. And I'm going to come up. I'm going to kiss this line right here. Okay, and go right across to this one. Again, don't worry about the dimensions right here. And I'm going to connect right back to the center. Okay, now there's easier ways to do this. Again, there's 1,500 different ways of doing this in here. So I'm going to come right here, hit escape to get rid of that. Ooh, see, that's how it did that? All right, we'll fix it now. Hit D for dimension, and we want half of 6.45. So I'm going to go 6.47 because of that shrinkage issue, divided by 2, and 3.235. Okay, 3.235. 5. Boom. All right, I'm going to do the same thing on the opposite side. 3.235. Boom. Okay. Hit escape, just break out that tool, and there you go. Now, when you highlight it like this, because I'm dead on center, that's already going to be centered, and I've done this in 2 pieces. So what I'm going to do now is I'm going to right click and hit press pull, and I'm going to go 10 millimeters. We know that's how thick it is. And boom. Okay. We have just made a spline. Only problem is we need 6 of those. Okay. Well, not a problem. Let's get in here. Let's go up to the top, and let's go to the solid menu and create. I'm going to come down to pattern, circular pattern, because that's what we want. Circular pattern. Now, here's where it gets a little tricky. If I go in, I need to click this surface, and rotate around here and click this one right there. Okay, so those are 6. My axis, I'm going to go on that same axis. Now look, it pulled up. How many do you want, Dan? Well, let's go with 6. Okay, got 6 on the same center, using the same dimension that we sketched out in that little with the lines. So each one should be 6.47, and then we're going to click OK. Boom. There you go. You've just basically made a Harrison 44-tooth gear using Fusion 360 with basically the correct spline, with give or take. You may have to fiddle with them just a little bit depending on, I don't know the size of your gear shaft to perfection. Okay, you may have some wear, you may have some burrs, I don't know, but this will fit pretty darn well. I've done several of them, but you can see that the spline. Now what I wanted to point out is, why is this thing such a problem? Well, look right here. This angle right here will drive you nuts. How do you cut that? Well, this will take out the shaper, it takes out the milling machine, it does all that stuff. You've got 6, they're uniform, 6.47. You may have a cutter to do that with, I don't know. But I could print these in 3D in a couple of hours versus making a metal one. And again, these are change gears. I don't need a lot of strength. I just need to be able to take this gear and print one out, do what I'm needing to do, and mostly what it is giving me the ability to cut metric threads and a few things like that, and go from there. Now I have gears all the way up to 100. I even did a 127 one just for giggles. All done the same way. So Fusion 360, it generates the spur gear for me, and then from there all I got to do is sketch in these splines, and now this is ready to be basically created in 3D. So what I'll do from here is we will come up, we'll save it, and go user saved. Okay, and from here we are going to, let's see here, export. Alright, and I'm going to export an STL file right from here, 44-tooth demo. Alright, and then I'm going to export it. In my situation, I've got a folder set up in 3D Objects, and you see I've generated quite a few things. And I'm going to make a new folder. .44-tooth Harrison. Okay. Yep, typing class. True story, I was thrown out, believe it or not. Yep. And then I'm going to export it. What this is going to do is going to bring us a STL file that we're going to put into a 3D slicer. And from the 3D slicer, it's going to slice it into G-code, which is going to allow us to export it and do it on the 3D printer. This will take just a couple of seconds here. But long story short, you can get 360 personal, not for commercial use. You can get it for free. There's a little bit of a process to do it. Learning it, you really... What you saw me do didn't require any real skills. What it was finding out the tricks. Okay, so the 44-tooth demo is all done. Now I'm going to use Prusa Slicer right down here at the bottom. Okay, and I'm going to do this on my Prusa Mini. I have an Ender 5 Plus, the gigantic one. But from this, I'm just going to go ahead and come in and import. All right. And I'm going to go to 3D Objects, and we have that. Let's see here, the gear. Where did I park that one? YouTube demo. Here we go. There's the STL file, and we're going to open it in the slicer. Okay. There's a gear we drew. Excuse me. Rendered in physical form. Hey, that's pretty cool. So that, if I want, I can just take those, and if I want from here, I can actually generate 4 of them at the same time. Now, it's going to add to the printing time, obviously, but what's nice is you can actually do it. All right, right from here, it doesn't really matter where it is. And you can see it from upside and the downside. You say, oh, okay. Now from here, you just click slice. All my settings are already set up. I've got it set to the Prusa Mini, and just going to use PLA as the example for this one. Okay, it's almost done. And what I will do is I'll beef this one up. I've got it set to some fairly minimal things here. You see right here this perimeter, kind of this yellow, it's only showing 3. I've got to go to the printer settings and layers, perimeters, vertical shell. I'm going to set that to 10. Okay. And don't worry, it disappeared, but it's going to be okay. What that means is now, look at this gear now. Now there are 10 shells around it. So 10 hard layers all the way around the splines, as well as the outer teeth. That's going to be as strong as it's going to get. This thing, again, is not going to be indestructible, but it's going to be fairly solid. Now, there's some cool things you can get in here. Is you can actually decompose it. All right, see those squiggly lines? That's the infill. I think it's using a gyroid in this one, and you can change those settings there. It's at its base level, and then as it comes up, it's going to draw in those for the infill. I've got the infill only set at 15% right now. I will break that up to, well, let's go 40%, and I'm going to slice it again. Hopefully this is some use to you. Again, this is not, it's very difficult to get started, but once somebody gives you a hint or 3 or 5 or 12, it's not bad at all. Okay, and it's going to tell me how long it's going to take. So I've got 40% infill. I've got 10 outer layers. That really doesn't change the print time a ton, but it does make this thing a lot stronger than what it would have been. Okay, that gear, the way it's set up, will take 12 hours and 54 minutes. Just to give you an idea. Okay, long printing time, that's fine, but that would be a very 40% infill with 10 rings around the outer edge. It's going to be very strong for what it can be. Now the material is PLA, it's not super strong in itself. You can do this in nylon. You need a little bit better printer for that. But basically you see it right there. This green ring you see on the outside, it's just a brim setting right there. You can watch me do this. I can actually decompose. You can watch it shrink it up. The gyroid is supposed to be nice as far as an infill.